Okay, so after going through tangents and normals, right? So the second thing that we're going to look at is stationary points, right? So what are stationary points? So stationary points, they're also called turning points, also called turning points, right? So they're also called turning points. Stationary points are also called turning points, right? So what are these? These are points. So these are points on the curve, right? So these are points on the curve for which the gradient, right, which is dy dx, which is the gradient, which is dy dx of the curve is 0, right? Where the gradient of the curve at that point is 0, right? So that's those are stationary points, or also called turning points, right? So which means at stationary point, right? At a stationary point, stationary points or point, right? Dy dx is equal to 0. So that's what you need to know. At a stationary point, dy dx is equal to 0, right? Please grasp that. So once you grasp that, a turning point, dy dx is equal to 0. So it's not pair, right? So the tangent to the curve, right, is parallel to the x-axis. Let's say if we have a curve like this, right? So if we have a curve like this, right? So if a curve like this, right, here, so here is the turning point, and here we have a turning point, right? So if we draw a tangent here at this point, right, and then we draw a tangent at this point, right? So you see the tangent is parallel to the x-axis, meaning the gradient will be equal to 0, right? So the gradient is equal to 0. Let's say if this is point A and then this is point B, right? So point A, so that's a maximum turning point. So that's a maximum. And then point B, right? So what is a minimum? It's going to be a minimum turning point, right? So let's look at examples. Let's look at examples. Okay, first of all, let's talk about the nature of the stationary points. So we're going to talk about the nature of stationary points, right? Nature of stationary points. Stationary points, right? Right. So there are various methods that are used to determine the nature of the stationary points, right? So I'm going to teach you the simplest method that you can use to determine the nature of the stationary points, right? So you're going to examine the sign, right? You're going to examine the sign of the second derivative. So you're going to examine the sign of the second derivative to observe whether the stationary point is a maximum or the minimum, right? So if d squared y, the second derivative, so dx squared is less than 0, right? So it means there's a maximum. So there's a maximum value, right? And then secondly, if the second derivative, right, if the second derivative is greater than 0, right? If the second derivative is greater than 0, there is a minimum point. There is a minimum. So there's a minimum point. That's what you need to know, right? And then thirdly, so if the second derivative is equal to 0, which means there's a point of inflection. There's a point of inflection. So which means we have a point of inflection, right? So what is the point of inflection? So a point of inflection is a point which dy dx does not change sign, so there's no change of sign on either side of the point, right? So the gradient is not changing sign on either side of the point. That's a point of inflection, right? So we're going to look at an example. Let's look at an example, right? We're going to look at example 1, right? Example 1. Find the coordinates. Find the coordinates of the turning point. Find the coordinates of the turning points of the curve. Of the curve y is equal to x cubed, right? Minus 3 over 2x squared minus 6x plus 12, right? And determine their nature. Determine their nature. Okay, so remember what you said, right? If you want to find the stationary points, at stationary points, we know that at turning points or stationary point, dy dx is equal to 0. The gradient is 0, right? The tangent to the curve is parallel to the x-axis, so the gradient is 0, right? So dy dx is equal to 0. So if we have the function y is equal to x cubed minus 3 over 2x squared, right, minus 6x plus 12, right? So we're going to find dy dx first of all, right? Which means dy dx is equal to, what is the derivative of x cubed? So we're going to get 3x squared minus, if we differentiate 3 over 2x squared, so the power will drop 2. So it means 2 cancel 2, so we have 3x. So 3 over 2x squared, we have 3x. Differentiating 6x, we have 6. And then differentiating 12 is 0, right? So differentiate constant to get 0. So we know that at turning points, right? At turning points, dy dx is equal to 0. So dy dx is equal to 0. So we're going to say what? 3x squared minus 3x minus 6 is equal to 0. And then we're going to solve this equation, right? So if we're solving this equation, right, let's solve using the, all right, let's reduce it to its lowest terms. So we have x squared. If we divide by 3, we have x squared minus x minus 2 is equal to 0, right? So if let's use factorization method. If we use factorization method, we're going to get so we factors minus 2 and 1, so we get minus 2x minus 2, and then we have x plus 1, right, is equal to 0. So it means x is equal to 2, right, or minus 1. So these are our x coordinates. Now I want to find the y coordinates, right? So we're going to go into the original equation, curve, in the curve, right? So when x is 2, when x is equal to 2, right, y is equal to 2 cubed minus 3 over 2, 2 squared minus 6, 2 plus 12, right? So which means we get 2. So we're going to get 2 here. So it's 8 minus 2 squared, it's 4, then 2, it's 8 minus 6 minus 12, right? And then when x is equal to minus 1, right, y is equal to minus 1 cubed minus 3 over 2 minus 1 squared minus 6 minus 1 plus 12, right? So we're going to get what? We're going to get, so it's an improper, we're going to get 31 over 2, right? So that's what we're going to get. So the turning points, which means the turning points are what? Are 2, right? Are 2, 2. So these are the turning points, right? And minus 1, 31 over 2. So which means these are our turning points, right? So these are our turning points. And so how do you determine their nature now? Want to determine their nature? Remember, we're going to examine the sign of the second derivative, right? So which means we're going to differentiate this dy dx, right? So which means if dy dx was equal to 3x squared minus 3x minus 6, right? So the second derivative, dy squared, d squared y, and dx squared is equal to, we're going to get 6x minus 3. So that's the second derivative, right? It's the expression for the second derivative. And then we're going to slot the x coordinate here for this point first. So it's 6, 2 minus 3. So it's 12 minus 3. So we're going to get 9. Right. So it's a positive. So what does it mean? So which means 2, 2 is a minimum, right? Because it's a positive. The sign is a positive. It's greater than 0. So which means the turning point 2, 2, right, is a minimum, right? And then for the other point, right, we're going to get 6 minus 1 minus 3. So you're going to get minus 6 minus 3, which is equal to minus 9, right? So get minus 9. So this the sign is a negative, it's less than 0. So which means minus 1, 31 over 2, right, is a maximum. So it's a maximum point. It's a maximum turning point, right? So that's how we work. We find turning points, coordinates of the turning points, and to determine their nature. So that's what we had for today, the lesson today. Remember to subscribe, hit that subscribe button. So next time we'll do rates of change. That's the other application of differentiation, right? We're going to do rates of change. So thank you.